Hi guys, welcome to another episode of Learning Physics with me. And I'm currently using Microsoft Edge because Samsung Notes disabled its application for non-Android users. And I use a computer and I use an HP tablet, so I can't really use Samsung Notes. But I'm trying to find another application which I can use for opening the documents, which has more tools. But anyway, whatever it is, no problem. Let's go back to parts. I think this is going to be part 9 of solved past paper questions. This is um, force, density, and pressure. I think in part 8, we stopped on page 70. So let's start part 9. A uniform ladder rests against a vertical wall where there is negligible friction. The bottom of the ladder rests on a rough ground where there is friction. So there's friction on the rough ground. The top of the ladder is at a height h above the ground, and the foot of the ladder is at the distance 2f from the wall. Okay, so the diagram is describing everything here. Which equation is formed by taking moments? Which equation is formed by taking moments? Okay, so since the wall is rough, the ground is rough, of course there's friction, which is F in the towards the wall. And since the wall is smooth, there's no friction with the wall, we only have the normal reaction F. So I am going to take moments about, say, this point here. Let me try to take moments about that this point here. So taking moments about that point, this is going to be clockwise. Perpendicular distance will be this distance here, which is A. And F will also be clockwise. No, I can't take moments about that. Let me take moments about this point here. So we have W times perpendicular distance. This one will be F times perpendicular distance, which will be H. Then this will be the other way around. It will be anti-clockwise. Perpendicular distance will be A plus S. So we have W times perpendicular distance A plus F times perpendicular distance H. These ones are clockwise moments. Should be equal to the anti-clockwise moments, which is W times perpendicular distance, which is A plus A, that is times 2A. So it means our answer is automatically going to be A. F times A, the perpendicular distance of F from the point I'm taking moments cannot be A. So this is wrong. W times A, then twice W times A, this doesn't make any sense. W minus A, WA minus 2WA, this doesn't make any sense. So the answer is A. The diagram shows the atoms of a substance with the atoms at the corners of a cube. The average separation of the atoms at a particular temperature is 15 nanometers, that is times 10 power negative 9. Okay. When the temperature changes so that the average separation becomes 17 nanometers, by which factor will the density of the substance change? So remember, density is equal to mass over volume. And of course, we know that density is inversely proportional to temperature. And of course, as temperature increases, the substance expands. Density is going to be inversely proportional to temperature because density is inversely proportional to volume. So it means that the density is going to be a constant over the sides. I'll just say S cubed because this is a cube. So volume is going to be S cubed. So density is going to be a constant equal to a constant times S cubed. And in terms of temperature, okay, so that is going to be for the when the average separation of the atoms at a particular temperature is 15 nanometers. When the temperature changes so that the average separation becomes 17 nanometers, by which factor that will the density of the substance change? So for the first one, density is going to be equal to K divided by, I'll use 15 squared, cubed, Then for the second one, the density is going to be equal to K divided by 17 cubed. This is row 1, this is row 2. Or let me just call this one row and I call this one row 2. So when I combine the two, I'm going to divide the two. So row 2 divided by row is going to be equal to K over 17 squared times, I get the reciprocal. Sorry, 17 cubed, not squared. So times 15 cubed over K. So K cancels out. So it means that row 2 is going to be equal to 15 over 17 power 3 times 0. So 15 divided by 17, and this is power 3, which gives us 0.69 times 0. So this is 0.69 times 0. So it means our answer is going to be B by a factor of 0.69. As simple as that. A man weighs 240 newtons on Mars, where the acceleration of free fall is 4 meters per second squared. On the Moon, g is 2 meters per second squared. Which statement is correct? The man has a mass of 60 newtons. You can check. The man has a mass of 60 newtons. It can't be 60 newtons. Newton is the mass, the unit for weight. The man weighs 120 newtons on the Moon. Okay, so we know that weight is equal to mg. So 240 newtons on Mars should be equal to the mass m times 4. So that means the mass of the man is 240 divided by 4, which is going to be equal to 60 kilograms. So the mass is 60 kilograms for the man. Then on the moon we can find the weight on the moon, which will be the mass 60 times 2, which gives us 120 newtons. The weight on the moon is 120 newtons. So the answer is C. I may not check D. The man weighs 240 newtons on the moon. You can't weigh the same on the moon as on Mars, yet G is different. So the answer is C. A sealed cylindrical steel can sealed cylindrical steel can is situated below the surface of water. What is the origin of the upthrust? Remember, upthrust is equal to difference cross-sectional area times difference in pressure. So the upthrust is due to the difference in pressure. So the air pressure in the can is less than the water pressure outside. Now, the upthrust is difference in pressure between the top and the bottom of the object. The average density of the air and the steel is less than the density of water. The water pressure on the top, on the bottom, is greater than the water pressure on the top. This is true. The pressure here at the bottom is greater than the pressure at the top because pressure is equal to density times G times H. It increases with depth. So the answer is C. A cylinder of weight W is placed on a smooth slope. The contact force of the slope on the cylinder is R. A thread is attached to the surface of the cylinder. The other end of the thread is fixed. Which diagram shows the cylinder in equilibrium? For equilibrium, the forces acting should form a closed triangle. The forces acting should form a closed triangle. For equilibrium, the forces acting should form a closed triangle. So if this is acting vertically downwards, and this is acting in this direction, and this is the thread, so the tension is in that direction. So the question is, which diagram shows the cylinder in equilibrium? So a cylinder of weight W is placed on a smooth slope. The contact force of the slope on the cylinder is R. Okay. A thread is attached to the surface of the cylinder. That means there is tension in the thread. The other end of the thread is fixed. Which diagram shows the cylinder in equilibrium? Okay. So the easiest way to do this, I'll just use these three forces should be meeting at the same point, so that we can say they are coplanar forces. So this will not work for this. So these ones will not meet at the same point. Of course, these two would meet here, but this meets this one here. It also meets the other one there. These ones are not meeting at the same point. So let me check the second one. So here these forces are meeting at the same point at the center. That means if I combine them, it is easy for me to form a perfect closed triangle. So the answer is going to be C. So the three vectors are forming a perfect closed triangle. So the tension downwards, normal reaction, and these ones are acting at the same point. So therefore, they can easily form a perfect closed triangle if their magnitudes are considered. So the answer is going to be C. A uniform meter rule of mass 100 grams is supported by a pivot at the 40 centimeter mark and a string at the 100 centimeter mark. The string passes around a frictionless pulley and carries a mass of 20 grams as shown in the diagram. Okay, so there's a mass of 20 grams, so there must be a tension here which pulls in that direction because this is pulling like that, so the tension is in that direction. And the tension should be the same as the weight here. So it is a uniform meter rule, so its weight, its 100-gram mass should be somewhere here. The 100-gram mass should be somewhere here. 100 grams should be at the center. At which mark on the rule must a 50-gram mass be suspended so that the rule balances horizontally? So first of all, let's try to use inspection and see where is the moment greater. So this is causing clockwise moments. The tension is causing anti-clockwise moments, but the anti-clockwise moment is actually going to be this tension here, which I can say 20 times G. This is going to be 20 times G, and this is going to be 100 times G. So this is 20 times this distance is 60, and this is 100 times this distance here is 10. So it means the anti-clockwise moment is greater. Therefore, we need another force which causes we shall need another force which causes, because the anti-clockwise is greater, we shall need another force which causes a clockwise moment to counter. So I will simply say that 20 times G times the perpendicular distance, which is 60, should be equal to 100 times 100 G times perpendicular distance, which is 10. This is 10 centimeters times 10 plus another force. We need another force which causes a clockwise moment, so it will be 50 grams or 50 times G times X. This G is standing for grams. Anyway, it can be grams, not gravity. I didn't bother adding times 9.81, but later it is supposed to be times 9.81. It's supposed to be times 9.81, but of course I know it cancels out. Times 9.81, and you have to change these to kilograms. Maybe let me just do this systematically. Okay, so I don't want to change the mass to kilograms because I want to save my time. But because these are supposed to be forces, this is 0.1 kilograms. This is supposed to be 0.02 kilograms, and 50 is supposed to be 0.05 kilograms. So I'm taking moments above the pivot. So I would have 0.02 times 9.81, that is the force. Perpendicular distance, I will not change the distance, it will be 60 centimeters. This should be equal to 0.1 kilograms times 9.81. perpendicular distance is 10 centimeters. I will not change that. Plus 0.505. Perpendicular distance is not known. I will call it x. So just solve for x. 9.81 cancels. There's a 9.81 here. 0.05 times 9.81 to change it to a force, then times x. So 9.81 cancels. So x is going to be equal to 0.02 times 60 divided by, minus 0.1 times 10, then divide by 0.05. So this gives us 4 centimeters. So x is going to be 4 centimeters. X is going to be 4 centimeters from the pivot. Remember, the 0.05 newtons should cause a clockwise moment to balance the anti-clockwise. So it's on the right hand side. 4 centimeters on the right hand side, so it should be somewhere here. 4 centimeters on the right hand side. So the distance, it is going to be placed at a distance of 4 centimeters from the 40 centimeter mark. So it is going to be at 40 plus 4 centimeters, which is 44. So the answer is going to be C. Atmospheric pressure at sea level has a value of 100 kilopascals. Density of seawater is 1020 kilograms. At which depth in the sea would the total pressure be 110 kilopascals? So this is going to be easy. Remember, pressure is depth times density times G. So using the first one, 100 kilopascals is going to be H. Density is 1020 times G. Using the second one, okay, here H is going to be, this was 100 kilopascals, so this is times 10 power 3. So I think here H is 100 exponent 3 divided by 1020. That is 100 exponent 3 divided by 1020. So this is H is 98 here. H here is 98. Divide by G, which is 9.81. H here is approximately 10.0 meters after substituting G. Then for the second one, 110 times 10 power 3 should be equal to H2 times 1020 times G, which is 9.81. So this is going to be 110 exponent 3 divided by 1020 times 9.81. So that is that is approximately 11.0. So H2, this is H1, H2 is 11.0 meters. So at which depth is in the sea would the total pressure be? 110. So the depth here is going to be the difference between these two values. So this is going to be 11 minus 10, which is 1.0. So the answer is going to be A. At which depth in the sea would the total pressure be? 110. So you could also find a difference in pressure. To find that height, difference in pressure is going to be density times G times difference in H. So the difference in pressure is 10 kilopascals, which is 10,000, will be equal to density 1020. 1020 times G, which is 9.81, times the difference in depth. So So this is going to give us the change in depth from the previous one. So I will just add on I get H for this pressure. Atmospheric pressure at sea level is this. The density of seawater is that. At which depth in the sea would the total pressure be? 10 kilopascals. Okay, so the answer is going to be 1 meter. At which depth? Because we get atmospheric pressure plus the pressure due to that depth. So the depth is going to be 1 meter. So the answer is A. I don't need to do another method here. The diagram shows two liquids labeled P and Q which do not mix. The liquids are in equilibrium in an open U tube. What is the ratio density of P over density of Q? Okay. So first of all, pressure, I'll call it P1, or pressure due to P is going to be equal to density. Remember, pressure is going to be density G times H. So pressure due to the liquid P, of course, I'm ignoring atmospheric pressure because it is the same on both sides. So this will be on the left-hand side, this is X and X, that is twice X times the density of P, then times G. Then pressure due to liquid Q is going to be the depth. This is the height of liquid Q above this level. So it is going to be X density of Q times G. Of course, at equilibrium, the pressure on both sides must be equal. So at equilibrium, pressure at P due to P should be equal to the pressure due to Q. At equilibrium, the pressure on both sides should be equal. So I'll simply say 2x rho P times G should be equal to x rho Q times G. So G cancels out, X cancels out. So the question was what is the ratio of density of P over density of Q? So I'm going to make density of P the subject, divide by density of Q. So this means on the right hand side I have 1, divide by on the left hand side I have 2. So the answer is going to be 1 over 2, which makes it to be A. The vehicle is at rest on a slope. It is considered to have 3 forces acting on it to keep it in equilibrium. They are its weight, normal reaction, and friction force. Which triangle of forces is correct? So we check to see which one is a perfectly closed triangle for equilibrium. So if I move around the weight, I think this is closed. If I move like this, the other force is the opposite, so this is out, it is not closed. This is not closed because R is the other way around, this is not closed. If I move like automatically, this is not closed. We move like this, the other one is the other way around, this is not closed. So the answer is automatically A, because you can move in a clockwise loop to form a closed triangle. So those forces are acting on a body that is in equilibrium. All external forces on a body cancel out. Which statement must be correct? The body does not move. They may cancel out, but when there is a resultant moment, the momentum of the body remains unchanged. The speed of the body remains unchanged. The total energy, that is kinetic and potential of the body, remains unchanged. So all external forces on a body cancel out. So this body can be considered to be isolated. So we can say the momentum of the body remains unchanged. If all external forces acting on a body cancel out, then the momentum of the body remains unchanged. You can't say the speed of the body remains unchanged. After all, if all external forces cancel out, then the body may still move even if all external forces cancel out. It can move at a constant velocity or constant speed. Then the speed of the body remains unchanged. The speed of the body remains unchanged. The total energy, kinetic and potential of the body remains unchanged. When all forces, I think the most appropriate answer is going to be B. The momentum of the body remains unchanged if all forces cancel out. A uniform beam of mass 1.4 kilograms is pivoted at P as shown. The beam has a length of 0.6 meters and P is 0.2 meters from one end. Loads of 3 kilograms and 6 kilograms are suspended 0.35 meters and 0.15 meters from the pivot as shown. What torque must be applied to the beam in order to maintain its equilibrium? Let's first check the resultant torque. It is uniform, so its mass of 1.5 is acting at the center. Okay, so this is going to cause an anticlockwise moment about the pivot. This is causing clockwise moment. This is causing anticlockwise moment. So let's check. For the clockwise moment, I'll write CW for clockwise moments. We have 6 times 9.81 for the force times the perpendicular distance, which is 0.15. Answer: 6 times 9.81 times 0.15, that is 8.829 Newton meters, that is clockwise. For the anti-clockwise moments, we have 1.4 times 9.81 plus 3 times 9.81 times the perpendicular distance, which is 0.35. Let's check this. 1.4 times 9.81. Did I multiply by the perpendicular distance of 1.4? No. The perpendicular distance of 1.4 is this one here, which is, if this is 0.4, and so this is 0.1. Yeah, I think that is 0. No, is it 0.1? So because this must be the center, this distance here should be half of 0.6, which is 0.3. So this is times 0.1 here, times 0.1, then plus 3 times 10 power, times 9.81, okay. So times 0.1 plus 3 times 9.81 times 0.35. So this is giving me 11.6739. So we notice that the anticlockwise moment is greater than the clockwise moment. We just find the resultant, and I think the resultant is approximately 2.8 Newton meters. So it means the answer is going to be D, 2.8 Newton meters. So the answer is D. So the resultant, we have agreed it is 2.8 Newton meters. We just subtract this minus this. So the resultant is going to be anticlockwise. So the answer is, the resultant is anticlockwise. So we need another torque of 2.8 Newton meters clockwise to counter the 2.8 Newton meters, which is anticlockwise. So the answer is D. Two bulbs X and Y containing air at different pressures are connected by a tube P which contains two mercury threads. The density of mercury is 13,600 kilograms per meters cubed. Which pair of values of H1 and H2 is possible? Okay. So number one, we know that difference pressure, the difference in pressure depends on the difference in height, H times density times G. So on the left hand side, we have 16,000, that is the air pressure there, which should be equal to H1 times the density of molecule, which is 13,600, then times G, which is 9.81. Okay, so for equilibrium, of course, the pressure this side should be the same as the pressure the other side. So that gives us H1. On the right hand side, we have 8,000 should be equal to the difference in pressure, which I'm going to call H2, times 13,600, then times 9.81. Okay, so since pressure on X is actually going to be is greater, we see it is 16,000 compared to the other one. The pressure on X, the pressure due to X is actually greater than the pressure due to Y. So it means, what does that mean? These other quantities are the same. It is this one which is greater, so it means that H1 is greater than H2. H1 should be greater than H2. H1 should be greater than H2. So H1 should be greater than H2, not equal. H1 should be greater than H2. So you have to choose between A and D. But we can check that. We can check that by calculation. Of course, we notice that H is directly proportional to the pressure, and H1 is actually, okay, if I can divide those two equations, I will want to have H1 over H2 is equal to 1600 divided by 800, 8,000. So it means H1 is equal to twice H2. If H2 is, if I say H2 is 2, H1 will be 4, of course. But then, okay, let me check what H1 should be. So I have 16,000 divided by open brackets 13,600 times 9.81. Then times 100. That is 11 point. That is 11 point approximately 12. That is approximate. H1 would be approximately 12. And if H1 is 12, the other one should be 18. So that means the answer is going to be automatically D. When H1 is 12, if H1 is equal to 12, H2 is most likely going to be, because H1 is twice, H2 is going to be 6. We can check if it means, okay, so I think I forgot something here. We'll just add here plus pressure due to P plus pressure due to P, because the air pressure on the left hand side, when there's equilibrium, the air pressure here should be the pressure due to this height plus the pressure of P. Then the air pressure this side should be pressure due to this height plus the pressure of P. And when you subtract, of course, when you subtract the two equations, I had skipped that part. When you subtract the two equations, you have 8,000 equals to, that will be H1 minus H2 into density, which is 13,600 times G, which is 9.81. When I subtract the two equations, this equation and this one, when I subtract them, P cancels out. So it means H1 minus H2 is going to be equal to 8,000 divided by 13,600 times 9.81. That means H1 minus H2 is equal to 8,000 divided by 13,600 times 9.81. So that is approximate times 100 change to centimeters. That is approximately 6. So the difference should be 6. But H1 is greater than H2. Like I said, H1 is greater than H2. Let me just leave out this part here of twice. Being twice, I will not divide. I will subtract the two equations because I had forgotten the other part of P. So H1 minus H2 is equal to 6. But you notice that H1 is equal to 6 plus H2, meaning H1 is greater. So the answer is automatically D. The difference is 6, but H1 is greater because it's 6 plus H2, so the answer is going to be D. A body is released from rest and falls vertically in air of constant density. Okay, not constant velocity. What statement about the motion of the falling body is correct? Statement about the motion of the falling body. It is released from rest, so that means initial velocity is 0. Of course, due to gravity, it must be accelerating. It accelerates due to gravity, so that is obvious. As it accelerates, its weight decreases. Of course, the weight of the body does not decrease because the weight will remain constant. So that one is not true. That part of its weight decreasing is not true. It accelerates initially at 9.8 meters per second. That is true. Initial acceleration is 9.8 meters per second, but the drag force increases, so its acceleration decreases. Of course, as it accelerates, speed is increasing, drag force increases with the speed. And if drag force increases with the speed, if a falling object weight is constant, drag force is in the opposite direction. As the speed increases, as v increases downwards, drag force increases upwards, so the resultant force decreases. So it means its acceleration decreases. So the answer is going to be B. As speed increases, the drag force increases in the opposite direction. So eventually, its acceleration decreases because to reach terminal velocity, it will reach a constant velocity. So the answer is B. A horizontal bar is supported on a pivot at its center of gravity. A fixed load is attached to one end of the bar. To keep the bar in equilibrium, a force F is applied at a distance x from the pivot. How does F vary with x? How does F vary with x? So this is fixed. So what happens because it must remain in equilibrium, if x increases, then F should decrease for equilibrium so that the product F times x is always constant. So as x increases, F should decrease. Okay. But then, can this be a straight line? Suppose x 10 goes beyond. Of course, there's a limit on x. There should be a limit on x. To keep the bar in equilibrium, a force F is applied at a distance x from the pivot. So first of all, we shall remove this one, directly proportional. These ones, as x increases, F is also increasing. So we have to choose between two, A and B, because as x increases, F must decrease. But is it going to be a straight line? Why won't it be this one here? Because this one means when x is 0, there will be a force F. F will be a certain value. There will be we can determine F for which x is 0, which is practical because when I extend this, it cuts the y-axis. at a certain value. It means I can determine f for which x is 0 and there is equilibrium, which is practically not possible. So it means the answer is going to be B. I may not determine easily f for which x tends to 0. Neither will I easily determine x for which f should be 0. So it means the graph is going to be an exponential curve. So the answer is going to be B. The diagram represents a sphere underwater. P, Q, R, and S are forces acting on the sphere due to the pressure of the water. Each force acts perpendicular to the sphere's surface. P and R act in opposite directions vertically. Q and S act in opposite directions horizontally. Which information about the magnitudes of the forces is correct? Of course, this one and this one, the forces must be equal. F due to S must be equal to F at Q, because force is equal to pressure times cross-sectional area. And for the same area, the pressure is the same at the same depth. So S and Q have the same force. But then the force at R is greater than the force at P because R is at a greater depth than P. So let's check the options here. S and Q are equal. We can see S and Q are equal, but R should be greater than P. R should be greater than P, or P should be less than R. So the answer is going to be A. P should be less than R and S should be equal to Q. So the answer is A. A hinged trapdoor is held closed in the horizontal position by a cable. Three forces act on the trapdoor: the weight of the door, the tension T in the cable, and the force H at the hinge. Okay, so this is shown here. Which list gives the three forces in increasing order of magnitude? Of course, the weight will not change. Increasing order of the magnitude. So if we look at the length of these vectors, if we look at which list gives the three forces in increasing order of magnitude, increasing order of magnitude. A hinged trapdoor is held closed in the horizontal position. In the horizontal position. Okay. So if I just consider the length of these bars, so this one is smaller than this one. So this is going to be the smallest, followed by this one, followed by this one. If I just consider the length of these bars, because the length are representing the magnitude of these forces. So increasing order of magnitude, it is W first, followed by H, then T. So the answer is automatically C. I just looked at the length of the lines. A borehole of depth 200 meters contained both oil and water as shown. The pressure due to the liquids at the bottom of the borehole is 17.5 megapascals. The density of the oil is 830 kilograms per meters cubed, and the density of water is 1000 kilograms per meter cubed. What is the density? What is the depth x of the oil? So first of all, at the bottom, if we consider the bottom, the pressure at the bottom is going to be the pressure due to the water plus the pressure due to the oil. And the pressure at the bottom of the borehole is 17.5 mega. So it is 17.5 times 10 power 6 will be the pressure due to the water. And the pressure due to the water is going to be density of water, which is 1000 times G, which is 9.81, because pressure is density times G times H. 9.81 times the depth, which is going to be at the depth of water, or the height of water is 200, 2000 minus x, then plus the pressure due to the liquid, which is oil, which is going to be density, which is 830 times G, which is 9.81 times x, which is the depth. So I'm going to simplify this. I'm simply going to okay, let me just simplify this. So 17.5 times 10 power 6 equals to 1000 times 9.81 times 2000. So I have 196,000. Those are 5 zeros. Minus x is going to be 9. I'll just add 1000 times 9.81, because that is x, times that is minus x, then so times -1 plus, because this is also x, so I'll just add plus, open brackets, 830 times 9.81. So I'm getting a minus 1676x. So it is minus 1676x. Okay, so now I just solve this. I take this on the other side, so I'll say 17.5 exponent 6 minus 196, 1, 2, 3, 4, 5 zeros. Then I'll divide this by negative 1676. So I am getting 1252. 1252. I hope I did this carefully. So x is 1252 meters. So it means the answer is going to be probably D. Maybe it's just as a result of rounding off. I'll check this again. 1000 times 9.81, that is x. So of course this, because this is minus x, so this is going to be negative, so I'll say times -1. Then I add this plus, open bracket, the density is 830. 830 times 9.81. So it is negative 1667. No, not 76. I made a mistake here. So it's minus 1667 minus 1667.7. 1667.7. So I now subtract on the other side. So 117.5 exponent 6 minus 196, 1, 2, 3, 4, 5, divide by negative 1667.7. Okay, so I'm getting 1259. That is 1259. I think I made a mistake in one of these. I'll check it again. 1000 times 9.81 times 2000. It's 19620. 19620,000. So it's 19620,000. I think that's where the mistake was. So I say 17.5 exponent 6 minus the answer, divide by 1667.7. Yeah, so that is 1271. So it's 1271 meters. So the answer is D. The formula for hydrostatic pressure is P is equal to rho GH. Which equation or principle of physics is used? Of course, here the answer is automatically A. We have already seen this, because pressure is force over area. This is the weight over area. This is mg over area. This is density times volume for mass, then times g over area. So mass is density over volume. We have used A. An archer draws his bowstring back to position X. The bowstring and the arrow are shown. The tension in the string is also shown. Then he draws the bowstring back further to position Y. The resultant force on the arrow is greater when the arrow is released from position Y. What is the increase in force? So here we shall just resolve this in the horizontal because they are both 100 newtons. So we'll say T in the horizontal is T cos. So this will be twice times 100 cos of 65. In this position, we have times 120 times 2 cos of 55. So we want the increase. So the increase or the change is going to simply be the difference between these two. So 120 times 2 cos of 55 minus 2 times 100 cos of 65. So I'll just press my calculator. 120 times 2 cos 55 minus 2 times 100 cos 65. So I'm getting 53. So the change is 53 newtons. So the answer is going to be D. Okay, so our answer is D. Water in a bath varies in depth from 20 centimeters at the shallow end to 30 at the end with the plug. The density of water is 1000. What is the pressure of the water acting on the plug? Okay, we want the depth, the pressure acting on the plug. So since the depth varies and it is varying linearly, then we can take the average depth. We may just take the average. No, I don't think. Let me see. So here it is 20 centimeters and it varies up to 20, up to 30. So we can just take pressure is going to be equal to a density times G times H. Okay, so this is going to be density, which is 1000 times G, which is 9.81, then times H, which is simply going to be 30 times 10 power minus 2. So this is going to be 1000 times 9.81 times 30 exponent, so times 1 exponent minus 2. So that is 2943, which is 2940. So the answer is going to be C automatically. So just take the depth above the plug. A cupboard is attached to a wall by a screw. Which force diagram shows the cupboard in equilibrium? So this is very easy. If it is in equilibrium, then if I prolong the forces, they should meet at the same point. They should be acting in the same. If there is there should be a possibility of these forces acting in the same point if they are to form a closed triangle. If it is possible for them to form a closed triangle, so let's check. I try to prolong these forces. So this is already meeting this one here. So it means they will never meet at the same point. Let me check B. I'll prolong R. And I'll prolong W. You just should use a ruler. And I will try to prolong S. So it means these ones can meet at that some point. So if they can act in the same point, then they can form a closed triangle. So the answer is going to be B. Without wasting time, the answer is B. A diving board of length 5 meters is hanged at one end and supported 2 meters from this end by a spring of spring constant 10 kilonewtons per meter. A child of mass 40 kilograms stands at the far end of the board. What is the extra compression of the spring caused by the child standing on the end of the board? Okay, so the weight of the child is going to be, of course, 40 times g, which is 9.81, and this is going to be causing anti-clockwise moment. It is, they didn't mention that it is uniform. So here we have a hinge. So the question is, what is the extra compression? So I'm going to find and I'm going to use anti-clockwise. Find the anti-clockwise moment first. It should be equal to the clockwise moment. So there should be a force here. If this is causing an anti-clockwise moment, there should be a force here which I'm going to find. So let's find anti-clockwise moment. The anti-clockwise moment is going to be equal to 40 times 9.81. Perpendicular distance is given as from the hinge is 5, so this is times 5. Okay, so there should be a force here. So this is going to be equal to 40 times 9.81 times 5. That is 1962. 1962 Newton meters. So that is the anti-clockwise moment. But we know that tension is equal to K times X from Hooke's law. So K is 10,000 times X, which we don't know. What is X? Let's check if we're given the compression. The compression, we don't know it is X. Okay. So remember the anti-clockwise moment is equal to this. And the tension is going to be 10,000 times the compression X. That is the tension force. This is the tension force. So for equilibrium, then we shall simply say that the tension force, which is 10,000 times its perpendicular distance, this is 10,000 x, times the perpendicular distance from the hinge, which is 2. This should give us the same moment as 1962 if we have equilibrium. So this should be acting in a direction where it should give us the same moment as the anticlockwise moment. So it should give us a clockwise moment to balance the anticlockwise moment, and should be equal to 1962 Newton meters. So what is X? So X is going to be 19 divided by 2 times 10,000. So that is 0.0981. The answers are given in centimeters. I will multiply this by 100. It is 9.81 centimeters. So this is 9.81 in centimeters. So the answer is going to be C. The graph shows how the total resistive force acting on a train varies with its speed. Okay. Part of this force is due to wheel friction, which is constant. Wheel friction, which is constant. The rest is due to wind resistance. Okay. What is the ratio wind resistance over wheel friction at a speed of 200 kilometers per hour? Remember, wheel friction is constant. And we know that wind speed, we're seeing that the wind speed increases with, the wind resistance increases with the speed. That is number one. When the speed is 0, the wind resistance must be 0. That's number 2. Wind resistance increases with the speed. When the speed is 0, it means the wind resistance is also 0. So the wheel friction, when there is no speed, the wheel friction is going to be 8 kilonewtons from here, because this is 1, 2, 3, 4, 5. So this is 8 kilonewtons. So when wind resistance is 0 for wind resistance equaling to 0, because for the wind resistance equals to 0 because speed equals to 0, then wheel friction is going to be, the wheel friction from the graph is 8 kilonewtons. Okay, then at speed of 200 kilometers per hour, total resistance, what is total resistance? Total resistance is 40. So total resistance is 40 kilonewtons. Remember the wheel resistance remains constant, the wheel friction remains constant. This is very important. The wheel friction is constant, and we have already determined it to be 80 kilonewtons. So it means the wind resistance is going to be 40 minus 8, which is going to be 32 kilonewtons. So we want the ratio wind resistance over wheel friction. So this ratio is going to be equal to wind resistance, which is 32 kilonewtons, over the wheel friction, which remains constant, 8. So the ratio is going to be 4. So the answer is 8. Gold has density 19.3 grams per centimeters cube. The volume occupied by a single atom of gold may be considered to be a cube with sides 2.6 times 10 power minus 8 centimeters. What is the mass of a gold atom? So mass is going to be density times volume. The density is 19.3 grams per centimeters cubed. Then the volume is going to be 2.6 by 10 power minus 8, but this is raised to power 3 because it is a cube. So I'll just press my calculator. 19.3 times 2.6 exponent minus 8, this is power 3. So I am getting 3.4 times 10 power minus 22. 3.4 times 10 power minus 22 in grams, since I didn't change the units. So the answer is going to be B. A cylindrical block of wood has cross-section area A and weight W. It is totally immersed in water with its axis vertical. The block experiences pressure PT and PB at its top and bottom surfaces respectively. Which expression is equal to the upthrust? We know upthrust is equal to cross-section area times difference in pressure. So it is going to be cross-section area. Remember, pressure at the top is smaller than pressure at the bottom. So the difference in the pressure is going to be pressure at the bottom minus pressure at the top. So it means our answer is going to be C. And lastly, for this part, the diagram shows a crane supporting a load L. A mass provides a balancing load W. The position of the load is such that the system is perfectly balanced with Wx equals to Ly. The ground provides a reaction force R. Of course, for it, we have no moment along that point. The distance x does not change. X is constant. If the load is moved further out so that the distance y increases and the crane does not topple, which statement is correct? So we have that Wx is equal to L times y. X does not change, and that what was W was a mass provides a balancing load W. Okay, so this one is also fixed here. So which statement is correct? Let's check the A. A horizontal force H acts on the base of the support column towards the left. They said the distance y increases. Of course, L is not changing. If the distance y increases, the distance y, we move this one further. If the distance y increases, so it means the clockwise moment increases. If the clockwise moment increases, h will not cause a clockwise moment to balance that, so this one is out. Still, h here will not cause a moment to balance, because the clockwise moment will have increased, then h will not cause a moment to balance that, so that one is also out. Let's check C. The reaction force R moves to the left. If the reaction force R moves to the left when Y increases, still it means it just increases the clockwise moment, because if the reaction force R moves to the left, it means it is now the point of the clockwise moment is still going to be greater. So it means this one does not help. The reaction force R moves to the right. If the reaction force R moves to the right, then it tends to reduce the distance between L and the point where the reaction force is acting. That means this distance here for the weight to the position where R is acting increases, so this one increases to try and balance the other one. So the reaction force R moves to the right, so the answer is going to be D. So if the clockwise moment increases, the reaction force R must move towards the right to tend to reduce the clockwise moment, or to tend to increase the anti-clockwise moment to counter the increase in the clockwise moment. So the answer here is going to be D. So since more weight moves to the right, so the position of the center of gravity shifts, or must shift to the right if no toppling is to occur. That's why the vertical line of R is shifting towards the right, to show that the position of the center of gravity extends to the right, so that the beam does not topple off or does not fall off. Okay, so that marks the end of part 9. See you in part 10. Bye bye.